Okay, so just to keep tracking, we used Splunk as a monitoring solution. We expanded it to business decision solutions, and now I'll show you how, after the time, our R&D team started to use big data, the real big data, raw data, to debug the Java code. Because PagSeguro, we use agile development system and Scrum, Kanban. We have more than 20 teams, 20 feature teams, so probably 100 Java developers committed in the same component, so it's a little bit chaotic. And when things go wrong in production environments, sometimes it's hard to see, hey, who committed the wrong stuff? And we started to use Splunk to find out this. I'll show you how. Okay, more than 15 teams. Our application distributed more than 16 hosts. We use a lot of virtualization on our company. So we have a lot of JMS, queues. We have jobs running in different machines. We have the web services, front-end and back-end communications, a large number of machines. So the first problem you have is to aggregate all those logs, because each of them has logs locally. And we started, we say we have Splunk, the backend, the new backend system using very little license, so we had free space. We have, initially I think we started with a 100 gigs license, and our new backend server was using only 10 gigs a day, so we have 90 gigs available. So we say, oh, let's throw all the data there and see what Splunk can do for us. Okay, I don't have dashboards here because this dashboard were built by the R&D team, and technical guys just like numbers. We don't do very beautiful things, but I'll try to explain here. Here we're using the anomalies command. Go to the side. Using the anomalies command from Splunk. What we have here. This is a lot of jobs. We have a machine that's on processing jobs. It's MDBs, it's processing from a queue. It's a job machine. And here we're listing all our job execution. I don't know how many of you are Java developers, but we use a Par4j tool. It's a tool that easily logs the time your methods are taking to execute. So we have Par4j on our jobs, and we have the information of the method, the class itself, the onMessage method, the time it started to execute, the end, the time it took, and it was successful. And we have all this information in Splunk, so we have the history. And what anomalies comments do for you? That the column we are calling unexpected. It shows you a number that indicates how much this time of execution is different from the history. So it's how much anomaly it is. So we can see here, it's chronological, okay? It's not ordered by unexpectedness. Let me find an example here. That's not a good dashboard. But see, this one is a very low anomaly. So it's running smooth. Probably no problem here. Possibly not problem here. But if you have, this dashboard doesn't have no great one. But if you have a number here near one, the much closer to one, the more different it is from the history. You look at this and you see, hey, there's something wrong with this job. It's usually running smoothly, and the last execution is anomaly. It takes a time, very different time to execute from the last one. Probably there's some problem here. Possibly there's some problem here. So if you have a production environment outage, you don't know what's happening. You look at the screen and you see a job that is very high unexpected. You probably, hey, something wrong here. You go to our concurrent version control or SVN and check the last commits and say, hey, I found someone commit wrong code here. Someone's loading a full relational database in the memory just to get the first results. It's usual. So that's an example of how we're using big data to debug Java code. Another interesting one, that's good. Here we have a log of our data access objects executions. So DO. Same concept. The data start, the data ends. But that's the interesting columns. We crossed the DAO executions with the Java garbage collection execution. So when we have an overlap of an execution of a DAO with a Java garbage collection execution, it's an indication that probably something is wrong there. You see, usually people, the commonplace people do mistakes in Java coding is using hibernation and load huge objects in the memory unnecessarily because eventually junior coders doesn't know how to use the tool in a good way. So if they load unnecessary huge data on memory, probably the execution of the garbage collection will happen there. And that's the time of the garbage collection execution. So same thing, if you have a production environment outage, something is wrong, you don't know what is happening, you just take a look at this dashboard and at glance you can pinpoint, hey, something wrong with that now. Same concept. You see that this one, its execution, again, I don't have a good example here because everything was working fine when I took this dashboard. I had no outage problem. I couldn't be working on the presentation if my production environment was down. That's why everything looks fine here. But we possibly could have a garbage collection taking 10, 15 seconds here. That's strange. Then you see the DAO, same thing. You go to the SVN, check the last commits, and hey, that's a bug here. That's an incorrect code. Okay, so that's true. We have a lot of more dashboards on the application, but it's interesting because it's a real big data extraction upon application logs. The guy that built those dashboards is no there other thing as the snitch. He turns in the wrongdoers. He finds out the people that's committing wrong code. Hey, that one, don't let him commit anymore.